excuse me, now we're going to kind of talk about exponents in a different way. So in class the other day, I thought that, so far we were talking about what happens when we multiply and divide exponents. Now we're talking about what happens when we add and subtract exponents and bases and stuff like that. So anyways, you'll see what I mean here in a second. So today we're going to talk about identifying terms and coefficients. There's tons of vocabulary. So especially in this video, what I would recommend is, well, A, the PowerPoint is up on the LMS if you need it. But B, instead of like waiting for you people to write down notes, feel free to pause the video and write down any notes that you want to. There's lots of vocabulary today. So anyways, we're going to talk about that. We're going to talk about combining like terms, describing polynomials with more vocabulary. We're going to evaluate polynomials, and then we're going to add and subtract polynomials. So in this expression, 4x cubed plus 6x squared plus 5x plus 8, there are some various terms that I like to use and we use in math, and so here I'm just kind of sharing those with you. So the terms in this case are anything, I think of them as anything separated by plus and minus signs. So for instance, there's a plus sign between the 4x cubed and the 6x squared, so hence 4x cubed is one term, 6x squared is another term. And you can see that there's a plus between the 6x squared and the 5x, so 5x is another term, and then an 8. So in this expression, we have 4 different terms that we can kind of look at. The leading term in this case is going to be 4x cubed because it is the one that's in front. And in standard form, which we'll talk about here in a couple minutes, you basically write expressions and polynomials in this case from the highest degree exponent down to the lowest. And then the next thing we talked about is numerical coefficients. Remember, coefficients are the numbers in front of the variables. So here, there's a 4 in front of x cubed, so 4 is a coefficient. There's a 6 in front of x squared, so 6 is a coefficient. There's a 5 in front of the x, so that is a coefficient as well. 8 in this case is not a coefficient, but there is a special name for it, and that is called a constant. So in this case, the constant term is 8. So again, terms separated by pluses and minuses. Leading terms, go ahead, it's going to be the one that's in front. The coefficients are the numbers in front of variables. That's the way I remember it. And then your constant terms are just going to be your numbers. So if you want to pause, write this down. Moving on, identify the coefficient of each term in the expression and give the number of terms. So looking at 2x cubed minus x, I think there are 2 terms. The first term I see is 2x cubed. The second term I see is a negative 1x. Now, you have to be careful because when we're talking about coefficients, there is a number in front of this x, but you just can't see it. And that number is going to be negative 1. So we're talking about our coefficients here. We're talking about both 2, because that's the number in front of the x cubed, and then a negative 1, because that's technically what's in front of your x. More vocabulary. The degree of the term is the sum of the exponents. Sometimes. I don't like how they put this. I probably would have reworded that. So this is more of the... Oh, wait. Sorry, it just clicked. The degree of a term is the sum of the exponents. The degree of a polynomial is the greatest degree. So sorry, I didn't read that right yesterday in class, or Wednesday in class, so I'm sorry about that. So looking at the term 3x to the 4th, this one has an exponent of 4, so we're going to say that that's a degree of 4. Now, another way that I, if it's a struggle for the degree to try to figure that out, another way that I think about it, is I think 3x to the 4th is 3 times x times x times x times x. So I ask myself, how many x's do I have in this term? And the answer is going to be 4. How many x's do I have in the term 5x? 1. How many x's do I have in the term negative 7? 0. But here's where it comes with the sum. If I have a term like 2x squared y, if I have an exponent of 2 there, there's technically an exponent of 1 there, remember? So that's going to be a sum of 3. So the degree of this one is 3. But when we're talking about polynomials, I wish they would have separated these. This term has a degree of 4. That has a degree of 2. This has a degree of 0. Remember, I'm just counting the number of x's here. And so this one has a degree of 4, so that's going to be that. This one has a degree of 1, degree of 0, so we're going with a 1. This one, that's a 3, 2, 2. The highest one is a 3. And then this is a 5. And this is a 6, but you always take the highest one. So they put this one in here because they want you to know that even though you have x to the 5th there and x to the 6th there, it's always going to be the higher one. Okay, so take a pause on this, write these down if you need to. So I'm just going to put all these up there. So there's different ways that we can name polynomials. So polynomial with one term is called a monomial. 2 terms is called a binomial, and 3 terms is called a trinomial. So some examples of a monomial are just 9m, one term. Negative 6y to the 5th, one term. A squared, one term. And 6. So the one that's probably the hardest is like remembering that just a constant is a monomial. A polynomial with 2 terms would be something like negative 9x to the 4th plus 9x cubed. Those are 2 terms. Again, terms are separated by plus or minus signs. So here my term is 8m squared and 6m, 2 terms, binomial. Down here, I've got 3 terms. So I've got a 9m to the 4th, a negative 4m squared, and a 6. If I asked you what the degree of this polynomial was, you would see that here's a 2, here's a 2, here's a 0. So my degree of this one is going to be a 2. Okay? Again, you can have fractions and as coefficients, right? The numbers in front of the variables, that's totally fine. And then here, just because it goes from the 5th to the 2nd doesn't mean anything. This one has a degree of 5, so there's something unique about that one, but that one still has 3 terms. Okay, so the first term is negative 3m to the 5th, the second term is negative 9m squared, and the third term is 2, because here's my minus sign here, here's my plus sign there. So they have to be separated by them. Just because there's one in the front here doesn't mean that that counts as like an extra term. Okay? So this says, and we're not going to simplify because we're going to talk about that in a second. It says, give the degree and tell whether the simplified polynomial is a monomial, which would be 1 term. Remember, binomials is 2 terms, trinomials is 3 terms, or none of these. So the first thing I do is I say negative 6x cubed is 1 term, and 3 is a 1 term, so I know I have a binomial. And then which degree? Well, this has a degree of 3, this has a degree of 0, so I would say it's a 3rd degree, I'm going to run out of space, sorry, binomial. So that's my official name of that one. So again, it's a binomial because there's 2 terms. It's a 3rd degree because my highest exponent is a 3. Don't do that one. What I want you to do is I want you to try 5x squared. I'm going to combine these ones to give me a plus 4x plus 3. So take a second to try that one. Okay, so I see this is my first term. I got my plus sign. This is my second term, plus sign, third term. So we're dealing with a trinomial. And then this has a 2nd degree. That's a 1st degree. That's a 0 degree. So I'm saying this is a 2nd degree trinomial. Okay, so hopefully that makes a little bit of sense. And then they throw this thing. Sorry. We've done this twice already. So when we've done this before is that we were given some expression, we were given x equals this number, and we had to plug that into the expression. The second time we did it is when we had both an x and a y, excuse me, and we had to plug the x in where the x went and the y in where the y went. For some reason, they're doing it again. I don't know why. But here's the key with this one. Remember, Remember, I write it such that anywhere I see a variable, I stick parentheses. So now that I know that x equals 2, I'm going to put a 2 in there and a 2 in there. Now, this is where it gets a little interesting. I have 4 times 2 squared. Remember PEMDAS, excuse me. So I'm looking for parentheses. I put them in there. Next thing I have to do is exponents. So in this case, we're not going to do 4 times 2 first and get 8 and then square it. We're going to do 2 squared first and get 4. And then 4 times 4 is 16. 2 times 2 is 4 plus 3. Left to right, that's 12 plus 3, which equals 15. So the biggest thing with these is now we're dealing with exponents. So you always want to do the exponents first and then multiply your coefficient in. Okay, so that's the goal here. So go ahead and try these. Now be careful. So for this one, we have y equals 1, but for B, this one, we have y equals negative 2. Okay, so this one, I think they do it for you. Yep, so they just highlight it in blue. So you're going to plug in a 1 there. So remember, 1 cubed is going to be 1 times 2 is 2, plus 8 minus 6. I think you're going to end up with 4. And this one you have to be careful. So you're going to do the exponent first. So negative 2 times negative 2 is positive 4, but times negative 2 is negative 8. So you get 2 times negative 8, which is negative 16, plus 8 times negative 2, which is also negative 16, and then minus 6. So you're going to get a negative 38 there. Okay. More vocabulary. I know you guys are excited. All right. Recall like terms have exactly the same variables with the same exponents. So here, we kind of did this earlier when we were solving for equations. But here, 19m to the fifth and 14m to the fifth are like terms because they both have the variable m and they both have the exponent of 5. Unfortunately, 7x and 7y, those are unlike terms, completely different variables, okay? The other thing is you can have more than just two that are the same. So I could have 6y to the ninth, negative 37y to the ninth, and just regular y to the ninth. Perfect. Over here, I cannot have z to the fourth and z. Those are unlike terms. Here, I can have 3pq and negative 2pq. Perfect. Now, here's what I kind of asked in class. So we have 3pq, but what if I had negative 2qp? Are those like terms? Well, the answer is yes. The reason why is because if you guys remember the commutative property, that says that 3 times 4 is equal to 4 times 3. So here, 3pq and negative 2qp are going to be the same thing because of the commutative property. Where here, if I have a 2pq and just a 2p, those are unlike. Even though they have the 2 and the p exactly the same, this one's missing the q. And finally here, this is where you have to be careful. This is 2xy squared, so the exponent is on the y, right? Same thing with here. But here, the exponent is on the y, but here the exponent moves to the x, so those are completely different things. So those are what we call unlike terms. So how do we simplify by combining these? This is what I do. I'm weird. You probably know that by now, but it works every single time. I see a 14y cubed. So in order for there to be a like term, there has to be a y cubed connected with the term. Well, my next term is negative 12y. That's not a y cubed. Plus 2y cubed. Hey, there's a y cubed. So I'm going to put a squiggly line underneath it. Negative 6y, that's not a y cubed, and 3y squared, that's not a y cubed. So I find all my y cubes and put squigglies on them. Let's go to the next one, negative 12y. So now I'm just looking for y's. Hey, there's one. There isn't one. And then this one, you can put whatever you want to around it. I did like some kind of cat face or something like that. So now I combine my squigglies. So 14y cubed plus 2y cubed. Now I combine my squares. That's a terrible square. Sorry, negative 12y minus 6y. And then I do my whatever that thing is, and that's 3y squared. So simplifying, I get 16y cubed. This one would be negative 18y. And this one is 3y squared. Now, I kind of hinted at this at the way beginning of the video. Standard form is when you're going to take your highest degree. So this one has a degree of 3. And then your next highest degree, and then your smallest degree, and you're going to write it like that, and this is my simplified answer. Because 16y cubed has a degree of 3, 3y squared is a degree of 2, and then negative 18y is just a degree of 1. So hopefully that makes sense. So go ahead and try these ones really quickly on your own. Okay, the first one, I think you're just going to combine those. Both of them are y cubed, so you can combine those to 2y cubed. The second one, the biggest key with this one, sorry, there's a garbage truck outside my window, is that you have to remember there's a 1 there. So we're going to do 1r squared plus 5r squared, which will give us a total of 6r squared plus 3r. Now, one thing to keep in mind, sometimes you might be asked to simplify by combining like terms, but you have to ask yourself, are there any like terms? In this case, I have a 2x squared and just an x. Those are unlike terms. Can't combine them, so there's nothing you can do with that. Okay? All right. the last thing we're going to talk about today is we're going to talk about adding and subtracting polynomials. So there's two ways to do this. I'm going to show you both of them using this same problem because hopefully we're going to get the same answer for both ways. And then we'll kind of talk through reasons why you might like the one over the other, and it's really just a preference of which one you like. So here, when I'm adding, all I'm doing is combining like terms. So I've got a 3x squared there, a 5x squared there. I've got a x term there. I've got an x term there. And you don't have to use squigglies or squares. You can use whatever you want, but just something so you can decipher the difference. So some people like to use colors. So the x squareds might be blue, and the x's might be reds, and the 2's might, or the constants, right, might be green. Anyways, so I've got a plus 2 there and a minus 4 there. So when I combine them, 3x squared plus 5x squared, I think will give me an 8x squared. Negative 7x plus 4x is going to give me a negative 3x. And then 2 minus 4 gives me a minus 2. So horizontally, that's the answer that I got. How you do this vertically is you set, oh, that's supposed to be a 7, sorry. You set up columns. So this, sorry, sideways, that's terrible. Wow. This is my x squared column. This is my x, and this is my constant. So here, 5x squared. I don't know why that's way off. I'm really sorry. And then minus 4. And then you just add up your columns. So 3x squared plus 5x squared gives me 8x squared. Negative 7 plus 4 gives me minus 3x. And 2 minus 4 gives me minus 2, which is the same exact answer as there. Okay? So that was a terrible, I don't know, something's going on with my screen, but you want it to line up like columns. Anyway, so hopefully that's helpful. Sorry, that's completely terrible. I don't know what's going on with my screen. I don't know what's happening. But anyways, columns are okay. I use them for subtraction. I'll show you why. Let's do an addition problem again. Take a couple of seconds. Try to figure this one out. Okay. Like I was saying earlier, they'd use colors here to kind of talk about their like terms. So when you solve it, you should get that, because the 2x to the fourth minus 3x to the fourth gives you negative 1x to the fourth. Negative 6x squared plus 5x gives you negative x squared, and then a 7 plus 2 equals a 9. Okay, so let's skip over some of these. Let's go to subtraction. Here's the way of doing subtraction horizontally. So I've got a negative here, right? So what I'm doing is I'm subtracting everything that's in this set of parentheses. So I'm subtracting this quantity of negative 3y squared plus 4y plus 6. So what I have to do is I have to distribute this negative to each one of those. So now my new problem is 7y squared minus 11y plus 8. So nothing changes in my first one, but in my second one that becomes a plus 3y squared minus 4y and minus 6. Then combine like terms. So that is my answer. So again, the only thing that's difference between adding and subtracting is you're distributing that negative first and then you're combining like terms. Okay, so what does this look like? Geez. I'm going to try to do it over here because I'm going to try to do this much better because that, I don't know what happened last time. Oh boy. It's kind of better. It's not the best. Okay, so now I'm going to put 7y squared minus 11y plus 8. So then I'm just going to put in here exactly what I have in my thing here. So another way you can do this is you can do it column at a time. So what is 7y squared minus a negative 3y squared? Remember, when you subtract a negative, you really add them. Then I have negative 11y minus 4y, so that's negative 15y. And then I have 8 minus 6, which gives me a plus 2, which is the same as the answer that I got there. So really you can do it either way you want. I'm sorry I messed up my horizontal or my vertical way, but it's really preference. A lot of people never learned horizontal addition, so for some people adding things horizontally just looks weird. But yeah, so I would recommend doing the vertical one if you feel more comfortable with that. And finally, this is going to be the end all be all, not that one. Let's try this one. Let's see what you got. I'll give you a couple minutes. Pause the video right now. Okay, so the first thing I would do is distribute that negative in the middle. So the 3t to the fourth plus 7t cubed minus 8t plus 3 stays the same. When I distribute that negative just to the middle part, I get a plus 2t to the fourth minus 3t squared plus 6. And then the n stays the same, so it's plus t fourth minus 6t plus 6. Jeez. Combine like terms. Start with your highest exponent. So a 3t to the fourth plus 2 to the t to the fourth is 5t to the fourth plus 1t to the fourth should give you 6t to the fourth. That 7t cubed has no other red ones, if you notice that. The green one has no other green ones, so that one's going to stay the same. You are going to combine the plums, so you get negative 8t minus 6t, which is negative 14t, and then you get 3 plus 6, which is 3 plus 6 plus 6, sorry. So that is going to be your final answer. Okay? So hopefully that makes sense. Honestly, if you can do that one, you figured out everything you need to know in this chapter.